Good morning and welcome to the Contemporary Issues class. We're going to go out of this world today on our discussion about exoplanets and alien life. Ron is going to lead us today. Exoplanets meaning those that are outside our solar system, that are farther out, that the Webb telescope is discovering, and discussion about alien life. What are the chances that there actually are other life forms in other parts of the universe? Ron's going to talk today about the mathematical chances of that, and we might even venture into the theological. What would God be like communicating with other alien species? Would it be the same Jesus type of story? We could talk about those kind of things too. So anything's possible. Nice to have you all with us. First, our usual announcements. Zoomers, please mute yourself on the lower left corner of your screen when you're not speaking. But we'd love to have your comments too. And we are recording this for future playback. And I want to welcome any first-time visitors. Maybe it's Nathan's first time today.
Yeah.
Nice to have you here.
Yeah.
And
Fun to hear about the planets.
yes.
Young scientific minds, love it.
Yeah. Yes. And let's see. Interesting sermon today. I want to give a plug for the sermon about the Pentecost and the Holy Spirit, and an interesting story that she shared. Everybody kind of talking after the sermon today about a story she shared about preacher Tony Campolo encountering some prostitutes in Honolulu, and really a good message that came out of that. So if you haven't heard the sermon, be sure and watch it on the replay. Anything's in the news we want to talk about?
There might be a budget reduction agreement.
You think we might avert economic chaos?
Looks like it may.
That would be so nice. It'd be avert economic meltdown across the world. That would be of the lesson. Yes.
I just want my social security check.
Yeah.
I just wanted to mention, I've talked to several friends that are here and already rebutted the story, but I think everybody in the class, I'm on AOL with them.
You got
And
hacked this week.
yeah, I got hacked, and people that I hadn't even thought of, I mean, close friends, I've communicated and so forth, but several that I haven't even thought of that might have thought it was true, but I was hacked. It was not me. Everything's going fine. I think particularly it caused people to respond because a lot of times widows are left with like nothing, it runs out or whatever, but you know, I'm comfortable.
Yeah, Helen's friends got, including me, got an email that said, hi, I'm in trouble, I need help. Would you go buy these gift cards? Which is a classic scam tactic, of course. And so,
But then the following ones were even more pointed and really just awful. Eric and I were talking earlier about it, and anyway, it's what's so awful is it's not just my friends, you know, that think, oh, poor Helen to go through this. It was awful to go through it because for 2 days, that's all I got done was answer emails about it, because they were seriously, you know, they didn't know because they live away, but we moved. It was work acquaintances mainly. But we hope you're okay. Yeah.
that's the world today.
Oh,
Isn't
isn't it
It's
awful?
scammed and hacked.
Yeah.
That's right. That's right.
But I have told several, you may remember Rev Mark was hacked. And
Yeah.
he would actually mention it periodically in his weekly emails, and yes, friends, it is still going on. So I'm not too thrilled to think that it can happen again, because they want to continue the story. But I have a really good password now. So I did that right away. Of course, the other one was good too.
Well, good reminder for all of us. Thank you. Okay, Ron, tell us about life in other places.
Okay, we're not only gonna talk about where life might be in our solar system and outside our solar system, elsewhere in the galaxy. We're also gonna try to talk a little bit about what advanced alien life forms might look like from just scientific analysis. So let's get started on this adventure through the universe. For those that are fans of Star Trek, that's the rock silicon-based creature from the one Star Trek episode. And then one of the early Star Trek episodes, the aliens, I can't remember what they were called.
The big heads.
Then if you're into Warner Brothers cartoons, you of course recognize, who's that guy and his dog down there? Does anybody recognize?
Oh, we always his name.
Marvin the Martian.
Marvin. Yeah,
Okay.
okay.
And then DC Comics had a character called the Martian Manhunter. So next one, a couple cartoons. And this one here shows aliens going, ooh, ah, they're looking at the Earth. There's obviously been a nuclear war going on. And then the guy with the test tube, great Scott, professor, our calculations are correct. The song was right. All we are is dust in the wind. Okay. It's a song by Kansas. So let's talk exoplanets. They come in a wide variety of sizes. Gas giants, planets like Jupiter and Saturn, that have massive amounts of gaseous content. And they can be hot enough to boil metal, or locked in a deep freeze. They can orbit stars at various speeds. Or there are even a couple rogue exoplanets that are out there, not connected to a star, but just whizzing through space. They're rare and few and far between, but there are some out there. Next one. So, of course, we're most interested in, well, all exoplanets, but particularly ones that might support life. And they call a planet that can support life a Goldilocks zone planet. Not too hot, not too cold, just right. So what is it got to be in the Goldilocks zone? Well, it's got to be the right distance from its star. Now, if the star is a bigger, hotter star, the planet's got to be further back. But there's a zone where a planet can be where the temperature is more or less right. You don't want it to be wandering through space, because once an exoplanet that's out there as a rogue planet wandering and it leaves its star system, it's going to become a frozen nightmare. And it might be a million years before it finds another star. It should ideally have an atmosphere and a magnetic field. We'll talk about that. And then finally, like a cake that needs time to bake, for life to get started and to advance and for evolution to happen, you need a period of typically billions of years. So you want a star that is long-lived, so that the planet out there can sit in a comfortable zone for a long millions and millions, probably billions of years, to let life and evolution take over. I want to mention back one. That's a picture of a boiling pond up at Yellowstone, and they have found these little dooheads called thermophils, bacteria, algae and stuff that can grow at temperatures of 430 degrees F and survive at that. Now, we don't know of any advanced life forms, but these simple single cell or multi-cell things can survive in those Yellowstone pools and give it some of its color. Okay.
Archaebacteria, correct?
Right. You've got to deal with hostile surfaces. If the planet's getting bombarded with meteorites and hot stuff,
I'm getting the reflection off the car.
Okay.
Sorry, go ahead.
that's going to start wiping out life. And you don't want the planet's surface to be a boiling cauldron where plates are getting flipped and tossed like something stirred in a skillet. Life can't get started. So you need a fairly steady environment for a long time on the surface. The planet orbit must be near circular, not elliptical, so that it stays, at about the same distance from the planet, to keep it, and you don't want it to be tidally locked. What do you mean by tidally locked? The moon is tidally locked to the Earth. That means we only see one side of the moon. So the moon goes around, it's rotating at just a rate such that its face that we see is always facing Earth. That means there's a dark side of the moon. Yeah.
Is that the
And,
same as geosynchronous, Ron?
No. Geosynchronous is, when they talk about a geosynchronous satellite, that is a satellite that stays over one point of the Earth continually.
Oh.
Yeah. Okay, next one. All right. So here's what you need for an exoplanet. And I also want to say, not only can you have an exoplanet support life, but you can have a moon potentially of a planet also support life. And we'll talk about that in a little bit. So again, you want a moderate temperature range for life. You like water. You want hydrocarbon molecules. Carbon is a magic molecule in a way because it forms tremendous numbers of bonds with other elements and can form long chain and complex structures. Good example is our DNA. That's mostly hydrocarbons, if not, there's some, I think, phosphates in there, but you want carbon. You want a low probability of meteorite bombardment, and you need a low cosmic radiation level. There are some planetary areas that get bombarded with a solar, either our sun or another sun, radiation that is so intense, it'll cook and fry and get rid of life. So you want, and then you want the steady environment, and again, a multi-billion-year life star. Next one. Okay, we're going to talk a minute about the numbers game. Our galaxy is estimated to have 100 billion stars in it. 100 billion. And our galaxy, the Milky Way, is 100,000 light years across. Yeah. Woo, that's a long journey.
Yeah.
Going to cards, if you play poker, the chances of being dealt a royal flush is 1 in 649,000. Which means most people, even if you play poker all your life every day, you'll probably never be dealt a royal flush. But if the probability of a sun having a habitable Goldilocks perfect planet was the same as being dealt a royal flush, nature can do wondrous things when it gets billions of chances. We would have, if the odds of a planet around a star were the same as being dealt a royal flush, in our galaxy, we'd have at least 154,000 of these planets. Royal flushes dealt to systems. But that odds are too long. They think about 80% of star systems have planets, which means almost every star, the vast majority of stars do have one or more planets. And that means, and the vast majority of the planets are 3 times the size of Earth or smaller. So they're within a beach ball balloon size, 3 times the size of Earth down to half the size of Earth. And they're not gas giants. So using this estimate, they think there's 60 billion rocky habitable zone planets in our galaxy. 60 billion.
But not all in the Goldilocks zone.
Right. In the habitable zone.
Oh, okay.
60 billion they think are in the habitable zone.
Okay.
So Mother Nature, given this kind of opportunity, we start dealing by the billions. The most incredibly unrealistic probable thing does happen. Next slide. We won't hammer on this too much, other than to say this is a for those brilliant students that do XY coordinate plots. This HR diagram, Hertzsprung-Russell diagram. Notice somebody screwed up the x-axis. It goes from the high temperature on the left 30,000 degrees Kelvin, down to the low temperature on the right. So I don't know why somebody did that, but when the guy put this together, it's been historical. But this is a plot of temperature of a star versus its luminosity. And our sun, see the red arrow pointing to it? It's kind of there in the middle. And they class stars according to what temperature range they're in. They call them an F, a G, an H, some other ones. And there's our sun. And they call that big band going across there the main sequence, because that's where they find most of the stars fitting that plot. Also on that diagonal line, the diagonal line going through our sun there is the diameter of the sun. If you jump up to the next diagonal line sloping uphill, that's 10 sun diameters. The next one up is 100 sun diameters, and then smaller ones down below. So you don't have to understand this plot other than to say stars come in a lot of sizes, a lot of temperatures, a lot of luminosities.
Ron?
Yeah.
Dumb it down.
Sure.
3 sizes.
Okay.
So our sun's kind of a middle size.
For a medium mass.
Square, yeah.
Yeah.
Right. Next one. Okay, so what do we know? For a long life of a star, you don't want the star to be too big. The big boys die out too fast. So I've got to say, like that big fat cat there. Star obesity is not good. The high mass stars are gonna not live long enough.
Right.
Okay, next one. There's more data on the surface temperature and some good stuff. And again, they rate them according to what temperature of the surface is. Again, that's that main sequence plot. Next one. Okay, NASA's got a whole array of satellites out there taking data. There's one whose abbreviation name is TESS, TESS, stands for Transiting Exoplanet Survey Satellite. And it has, when I pulled this chart out, it was only a year old, it had discovered TESS is particularly designed to look for exoplanets. It's got particular instruments to look at atmospheres or lack thereof, spectrums of different, and it's found, when I pulled the chart, the number was 285 exoplanets that TESS had discovered. Well, as of April 18th of this year, it's now in its 5th year in space, and it has found 329 new worlds. So it's racking up the discoveries.
Does it orbit or just keep going out?
I believe it's an orbit. It's a controlled orbit.
Okay.
Okay, next one. All righty, so there's Marvin the Martian peering through his scope, and the test planets by size. The Earth is, see the 2 blue strips there? The Earth is right in there in that peacock blue and dark blue zone. And that's the percentage of sizes of the planets. And we can see add 31% to 12% to 5%. Little math says almost half of them are either at least 30% the size of Earth or double the size of Earth. So at least half the exoplanets we're discovering are the right size compared to Earth. Next one. There's a little picture of Neptune.
Windy planet.
Yeah, and Neptune has a huge gaseous atmosphere around it, but it does have a core, an inner core, like a Tootsie Roll Pop, that has rock and ice. So it's got rock and ice at the Tootsie Roll core. Then it's got a mantle. It's got the next layer of the Tootsie Roll Pop that has water, ammonia, methane, and an icy form. So it's like a slush. But notice there is water. And then the atmosphere out there further is hydrogen, helium, and methane. So pretty cool. I think Neptune's one of the more visually aesthetic planets.
And it's got rings too.
Right. Okay, so what is an exoplanet? As of February 2023, the count of exoplanets was 5,250. That's a 5,280 feet is a mile, so we've got a exoplanet discovered for every foot in a mile right now. And there's a big line of candidates they're analyzing, almost 10,000. So you can see the numbers really going up.
Ron, is
Yeah.
Pluto an exoplanet?
You're
probably getting to that.
no.
So that's the
It's a
number.
dwarf planet.
Outside our solar system, we know, or we've discovered now more than 5,000 planets,
Yep,
not just moons and stars, but planets.
planets.
Huh.
And over almost 10,000 candidates that they're analyzing to affirm.
And are we seeing farther and farther out all
Yes.
the time?
Oh,
With
yeah,
the-
James Webb.
With the Webb telescope?
Oh, yeah.
Oh, yeah.
Okay, next one. So, here's one. This is not radio station KOI. But, planet KOI 3010. They calculate the probability of habitability for this planet 84%. It orbits an F-type star. The features of the planet are very similar to Earth. And it's one of the most Earth-like planets they have found to date.
And where is this one? Go ahead.
This one,
1,000.
1,075 light years from Earth. Yeah. All right, next one. I'm just gonna touch on a couple. Here's another exciting one. Kepler 442b. 1/3 larger than Earth. And it receives about 2/3 of the light that reaches our planet. So it doesn't get as much solar, but the guys have figured that, and the gals have figured this has a 97% chance of being in a habitable zone. That's pretty good. In fact, its numbers, when they crunch the numbers, say this planet is more inhabitable, mathematically predicted, than Earth.
Really?
Yeah. Next one.
Let's go there.
Okay. Then there's the planet TOI, and they found a bunch of planets on this one. And it's got, astronomers have discovered at least 4 planets in the habitable zone. And they've got at least 4 candidates just around this one star that are all in the Goldilocks zone. Pretty cool. One of only a few systems with multiple small habitable zone planets that we know of. This makes this not Toy Story, but TOI, more exciting to look at, and James Webb is probably going to take a closer look at it.
Are telescopes powerful enough to zoom in on these planets and see if there's any animals walking around?
No, we don't have that. We'll talk about what we can see.
We can see the planets themselves, but not right on the
No.
surface.
No.
Okay, just thought I'd ask.
Right. Okay, next one, skip over this one. It's got a couple tidally locked planets, but again, Toy 700 has several. Then here's another one, LHS 475b, rocky and almost precisely the same size as Earth. It's based on new evidence from the Webb telescope. Now, the bad news is it's a few hundred degrees warmer than our own planet. So life there has got to be,
More like Venus.
it whips around its star in about 2 days. And it's only 41 light years away. Okay, next one. Okay, Kepler 62. This is called the water world planet. It's an exoplanet believed to be a water world orbiting about the equivalent distance of Mercury. And it's 1,200 light years from Earth.
Another fail.
It is actually one of 2 possible habitable planets in its system. But that's exciting. The very fact that you say water world for an exoplanet makes the biologists jump with excitement.
And Kevin Costner too.
Yeah.
Yep. Next one. Okay, we're going to talk a little bit about the moons within our own solar system. Now, the moons within our own solar system, we can pretty much say, I don't think there's any people like intelligent aliens going around on them, but they think there's a pretty reasonable chance of several of the moons of Jupiter and Saturn having conditions that what I will say low life forms can be there, like maybe some, algae, some multicellular, biological organisms, stuff like that. And in your handout, there's, moons with our solar system, and it gives some of the top candidates. These are all, the four I've shown here, and these aren't the only ones, are on Jupiter and Saturn. But if you want to take this home and ponder over it, it does talk about some of the characteristics they've seen, such as, we're gonna, Enceladus, it's one of my favorites. Let's jump to the next slide, number 22. The Jets of Enceladus, sounds like a movie. If you look at the other handout you've got on Enceladus, it shows that they think there's a subterranean ocean down there under the layer, and it's covered by a giant ice layer, but there's these geysers shooting watery plumes.
Geysers.
Well, enough to pushing up and throwing these icy geysers up out of the surface. So and explain where the heat is coming from. Liquid water due to tidal heating and geothermal activity deep inside the planet.
Now, this two are hotspots.
Right.
Created Hawaii.
So that's pretty darn exciting.
So a billion years from now, these will develop into humanoid type creatures, right? But will our sun be around?
The bad news is on Enceladus, even though we think some life could get formed in those oceans down there, it doesn't look like favorable conditions for more advanced life forms to progress. But
Like her, his girl.
right, yeah, I had to throw that in there. That's DC's comic hero Saturn Girl, supposedly from Saturn, but if girls look that good there, a lot of guys will volunteer for that mission. But analyzing data from the Cassini spacecraft that went out to Saturn many years ago, they think there are complex organic molecules emanating from its liquid water ocean. And this moon is the only body besides Earth known to simultaneously satisfy all the basic requirements for life as we know it. Enceladus is considered one of our solar system's most promising candidates in the search for extraterrestrial life. Next one. We want to talk a little bit about sputtering and magnetic fields. As astronauts try to go out to Mars, we haven't yet, but one of the big concerns is when you go out there in your spaceship, you come out of the Earth's Van Allen belts and radiation and magnetospheres, and you expose yourself to solar radiation. Now, it's not going to zap you right away, but over a long period of time, it's bad for you. So what protects us? Let's jump to the next slide. The Earth has what we call a magnetosphere. We of course have a north and a south pole, but we've got a giant magnetic field around our planet. And that's of course what gives us the aurora borealis when the solar radiation strikes Earth's magnetic field. And this chart shows that solar wind getting diverted away. And that helps protect us down here. We can strip away the magnetic field of the Earth. We get bombarded with a much higher solar radiation. The magnetosphere is a region around the planet dominated by the planet's magnetic field. Other planets in our solar system have magnetospheres, but Earth has the strongest one of all the rocky planets. So our magnetosphere is stronger than Mars, Venus, and the other rocky planets.
That magnetic field.
It's the largely iron content, iron nickel magma deep inside the Earth. It's moving and bubbling around, and that's why your compass works. Not only does it help your compass work, but it helps protect your life.
On my phone.
Okay, next one. And there's an artist's visualization of Saturn.
Oh,
Saturn, of course, is so large, and it does have a magnetosphere, that Saturn's magnetosphere actually extends out far enough that it becomes a magnetic bombardment of its moons. And that means its moons get bombarded by Saturn itself, magnetic particle spray, and that kind of hurts life. On the other side of the coin, here you got a moon going around Saturn. It's getting the sputtering and particles coming off of Saturn. But a couple of the moons of Saturn have their own magnetic fields that are able to protect them from their own planet's bombardment. It just tells us that we like to see magnetic protective layers on a moon or a planet to allow life to go. We want to talk a minute about methonogens. They're on Earth. They're microorganisms that produce methane. And they're biological. If you study the chart of life, they're prokaryotic and belong to the domain Archaea, which is way down on the tree of life.
one of the kingdoms.
Right. And they're responsible for marsh gas. And they're in the digestive tracts of animals, including some humans. And they're responsible for methane content of belching and flatulence. Okay. So there are life forms called methonogens, and they don't need oxygen so much. They thrive on methane. Okay. So there's a moon of Saturn called Titan, and they think this has got lakes of ethane and methane. And they think, instead of Earth-like life, we could have some of this methonogen life going on there. It's been speculated life could exist in the liquid methane and ethane on Titan's surface. Don't smoke there, though.
No.
And such hypothetical creatures would take in hydrogen instead of oxygen and react it with acetylene instead of glucose. So again, don't smoke on this Saturnian moon Titan. Next one. Here's a really exciting discovery that's just come out in the last couple of months. They have not only found a exoplanet in this one system, but they found this giant asteroid belt. I mean, it's huge. It goes out as far as some of our planets. And they're using James Webb to take a closer look at this star. Star's name is, it's got this big asteroid belt and this dusty ring system around a star called Fomalhaut. Young hot star that lies 25 years,
So
light
that's,
year.
sorry, is
Oh.
that separate from the Kuiper belt thing?
Oh, this is out on another star.
Oh, okay.
But it's bigger than our asteroid belt's fairly thin on a relative scale, but this is a giant asteroid belt.
What are asteroids?
Asteroids are, let's call them little planets, smaller ones, and they come in a wide variety of sizes. But the star Fomalhaut's ring system has 3 nested belts that extend out 150 times the distance between Earth and the Sun. So this thing is way out there. And the rings are more complex than our Kuiper belt and the frigid bodies beyond Neptune. So this is this giant garden of asteroids that are just far more massive than anything in our solar system. Okay, let's get into what life might look like elsewhere. What might aliens look like? Couple cartoons. The one alien's looking over the shoulder of his buddy, fumbling in a handbook. Take me to your stove, you idiot. Give me that handbook. And then this one said, Farmer Brown dooms the earth when he grabs the alien leader by the head and shakes on it. Okay, and then of course, there's good old Marvin the Martian and his green dog. Next one. Okay, well, what do we need for life? Particularly to get to the more advanced forms of life, not just a single cell amoeba or whatever. Well, you need metabolism, a power plant. You need the ability to reproduce. You need the ability to evolve. Next slide. And that's a great poster, by the way, if you ever want to put one up in your kid's bedroom on evolution. But here's what we need in a life form. So before we even define these aliens, or they find us, we know here's what's going to be on their bodies. They're going to have sensors, either for visualization, large field with light sensing orbs of some kind, focus ability to zoom in, see something close, far, sound wave detection, like that means something like an ear, smell, sense of smell for detection of the environment and chemical, and tactile touch and feel. So, you can touch things, they can bump against things with nerves. So those are some of the things. There's likely an exoskeleton in their skin to resist blows, bites, and invasion of bacteria. There's reproductive capability, either asexual or sexual. Energy collection ability, that means there's got to be a way to get food. And that means also waste expulsion capability. Once you've taken in food, you've got to throw out the exhaust products, tailpipes. Heat temperature control, keep the body in some moderate range of temperature. Locomotion appendages. You either gotta, if you're gonna move around and look for food, you've got to have a locomotion method. That means flippers to swim, or wings to fly. 2 feet. Yeah, 2 feet. So we can expect locomotion,
Like a starfish.
and features to compete for environment, food, and compete with other of your own kind. So you need to be good looking. Peacocks, that's why plumage is on. They know in the mammal world, mammals evolve features to be attractive for sexual reproduction. Okay, a brain to control and manage all the above, to integrate all these sensors. Ability to evolve and adapt to change. And then symmetry is another thing you expect to see. You think of all the life forms on Earth, almost all of them are symmetrical. You draw a line saying there's a right leg, a right eye, left eye, even a right nostril, a left nostril. And that's partly because in cell division, cells don't divide into threes, they divide in two. So many chemical reactions and biological processes are splits, pairs, splitting off. So we expect to see symmetry in life. All right. Okay. Okay, now let's talk about what this means for our theology. Okay. So if we've got advanced life forms, particularly really advanced life forms, is
Speaking of advanced life forms.
is a deity concerned only about human life? Or is the deity, if the deity is also the creator of intelligent life elsewhere, if the deity cares about us, would the deity care about
Life on other planets.
life on other planets? So,
And how would then God communicate with them? Would it be different than the way he communicates with us? Because we have such limited brains, we can't, and it says in the Bible, you can't see me because you can't comprehend me. I'm not going to reveal myself to you because your brains couldn't understand. Well, what if there's a more advanced life form that could? Maybe God reveals himself more fully to them. I'm just thinking out loud.
All of those things that you mentioned had to be before you have life. Human life, if you wanna call it that, but that's all based on what we know here. We don't know enough to know whether that's what it would be like on another planet. Maybe totally different, not dependent on any of those things you just mentioned. So I don't limit, my theology doesn't limit God to that. Those, life on other planets may have existed long before it did here. So I'm open to anything. And I don't think that we have to limit it to what we only know. We are very limited.
As long as the televangelist doesn't go on TV and ask for donations to do a revival on Enchiladas. Send money.
Well, on that note, I thought it was interesting that they thought, life could breathe methane. Because I was like, well, there doesn't necessarily have to be oxygen breathing. But we were also wondering, is there any organization globally about coming up with a code of conduct for when we do meet other life forms, like a do no harm commitment, you know, like, so we don't just accidentally damage a fragile planet?
I think there's kind of been somewhat of an international agreement saying we won't throw trash on the moon. I have to look, but that's about it.
That's the thing,
I
though.
don't think we've gotten that far. I also want to mention, take home the thing on the Jupiter. There's two spacecraft being launched. One that's already been launched, there's another one going off this year. And they're going out to Jupiter to look at the moons of Jupiter. One of them's gonna take 7 years to get there, the other 8 years. And the one they launched first takes longer to get there than the one that's gonna be launched a little later this year. But this talks about some of the things they're gonna try to find out of those Jupiterian moons. Yeah,
This is a NASA launch, not Elon. Musk.
right, right. Correct. Okay, sure.
Can you give us some idea of the number of scientists working on all of this around the world? How that's.
Well, when we say scientists working on this, there's space agencies in many countries, even United Arab Emirates,
European
Japan,
Space Agency.
European Space Agency.
Okay.
Yeah.
Even Russia.
And there are people that are not directly working for NASA,
Even India.
but working for, just centers of academic excellence in biology that are very interested in data coming from other worlds, because it helps, as we understand life elsewhere, it helps us understand ourselves better.
Can we assume that they do a lot of collaboration there?
Oh, yeah, absolutely. Thousands of technical papers and analysis and trading of data. And if I've got to regret it, I've got to wait 7 or 8 years before we get the data. And I also was reading an article, they want to send a probe out to Uranus. That's the good news. The bad news is they probably wouldn't launch it till 2030s. And it wouldn't get out there till the 2040s. And I look at my lifespan and say, no, something I missed.
So Ron, do you think we have been visited by aliens from another planet? Maybe just doing intelligence gathering, looking at what we're doing? Do you think that's likely?
I kind of agree with Neil deGrasse Tyson. I think the odds are greatly against it, just because of the it looks insurmountable, trying to exceed the speed of light.
This visit so far.
Yeah.
For somebody to get to us.
Right.
Okay.
I mean, 100,000 light years to get across our galaxy, and you can't exceed the speed of light. Also on UFOs, if you look at all the evidence I know there's TV shows on it all the time, but still, nobody's been able to come in with really irrefutable evidence. And after all the sightings we've had, I would have expected at least a few cases of stronger, more compelling evidence.
They probably just took a look at it, turned around and went home.
It's like that Calvin and Hobbes cartoon, the surest sign that there's intelligent life in the universe is that they haven't tried to contact us. Also, if Jesus is needed for salvation, well, he's got a busy schedule. His calendar's got to be filled trying to visit all these places. So, yeah. It does twist our theological perspectives in terms of why are we here? Where are we going?
I've got a story.
Go ahead.
When I was teaching astronomy at Rock Canyon High School, I had this little Korean boy come up to me, I taught freshman. And he said, excuse me, Mr. Schmidt, he said, I'm a Christian and I don't believe in the Big Bang Theory. I said, that's okay. I said, I'm not here to convince you one way or the other. I said, however, I don't see any contradiction between a creation view of the universe and the other view of the universe, which is the Big Bang. I said, I think they're complementary, because if God spoke the universe into being, it happened just like that. And that's what the Big Bang Theory teaches. That happened in the millionth of a second, and it's expanding. And not just expanding, but this is the fascinating part. It's expanding and accelerating. The Big Bang. All of these planets are accelerating, or stars, I should say, are expanding away from the point of the Big Bang. And now James Webb is able to almost look back to the very beginning. It's almost able to look back 15 billion years to where the Big Bang began. It's that powerful of a telescope.
Seeing the light that came off of.
Exactly.
the Big Bang.
Stretched. Yeah.
Yeah.
It's
That's
because they're moving away the Doppler-like effect of light.
the red shift, yeah.
Speaking of young people, can I ask Nathan what he thinks about aliens? Do you think there is life somewhere else in the universe like ours, Nathan?
Yeah, somewhere,
You do somewhere?
yeah.
You think they'll come visit us sometime? Maybe not. It's fun to speculate on these things, isn't it? Ron, what do you think will be the advances we see in Nathan's lifetime, when Nathan's as old as us?
Well, we're gonna see more probes sent out to more distant moons and more distant places in our solar system. So we'll definitely have more data there. We're definitely gonna get more using spectroscopy. We're looking at light that's coming through atmospheres of these exoplanets. And by looking at the light coming through and not coming through those atmospheres, we're figuring out the chemical composition. We're finding out there's some watery worlds out there. And as we get a better idea of some of the chemistry and the elemental compositions, it'll give us more clues.
Because each of the elements in the periodic table emits a certain wavelength of light. That's what he's talking about. That helps identify what's coming off the planet.
Here's a pretty, not very pretty. There's a life form somebody has. Notice it's fairly symmetrical though, if you come up. There's 4 orbs and even numbers of things also from the life form.
Except for one Mel.
Yeah.
Because we don't know.
One Mel.
Oh,
I want to offer our Zoomers a chance to jump in here if you'd like to, Susan or Toby.
Actually, that's my husband Dave, but he's on a mic.
Oh, that's right, there's Dave, I see, yeah, you're Toby, sorry, yeah, would you like to make any comment or question, Susan or Dave? Okay,
I want to throw in a theological comment. The LDS or Mormon church teaches that there's a planet Columns out there in space somewhere where people kind of go to. I think the concept of heaven is better supported by the concept of a multiverse, an alternative universe that you could break into somehow. I'm not saying that's what my beliefs are, but I think that's mathematically and scientifically, that's the highest probability
Dark matter?
of where I have it might be.
No, not
Yeah.
dark matter.
Because with all these planets we're talking about, the known universe, we're talking about this dimension, right? As we can try to describe that.
Yeah.
The reality we know, but there's possibility of many other realities we don't know.
Of course,
Until Einstein, we thought gravity controlled the universe, period. But after Einstein, then we've learned that why is the universe expanding and accelerating in its expansion? Where's that energy coming from? That's like holy grail. Right, in astronomy now, where's that energy coming from to make it, normally things would, normally,
Slow
if
down.
gravity's governing universe, things would slow down.
I mean, there's a lot we don't know.
Well, we only see 5% of the known universe. That's why it's
God's big.
God's big, that's right.
exciting.
Ron, do we still have those like microwave plates that are aimed out at the outer space? And
Radio
we
telescopes?
hope to get a message.
Yes.
If anybody sends a message
Radio.
by radio waves, that we could get that and believe we got a message from somebody.
yep, that's still being done. The rock, how many heard of the Carpenters, the singing Richard?
Close to you?
Yeah, well, they also did a song calling occupants of extraordinary craft. It's worth going home and asking Alexa to play,
Oh,
calling occupants of interplanetary craft. It's the theme song of an interplanetary society.
Okay.
Wow.
What other movies can we think of? What's the one having to do with the Wyoming,
Oh, close encounters of the third.
good one to watch?
Yeah.
Yeah.
I also want to personally thank the
Richard Driver.
editors of DC Comics. I loved DC Comics when I was a kid, Green Lantern, Flash, and Superman. And Green Lantern, one of the first issues, broke through the dimensional barrier into the anti-weapon world of Ford. So what did these comic books do to me? Unlike my mom, who thought they were bad for you, I felt that they opened my mind
Yeah.
to science fiction. And, I
Yeah,
really enjoyed them. Superman, the Phantom Zone,
Yeah.
and Flash had a cosmic treadmill where he would go through time barriers. So my thanks to the editors of DC Comics in the late 50s and early 60s for opening my scientific mind and cultivating it. So tell mom, gives you some good comic books.
What are your favorite science fiction books or TV shows or movies?
I love the original Star Trek
right.
and the follow-on Star Treks.
Do you think it's possible we could ever beam up somewhere?
That looks right now, the sheer number, the fact that there's more than 1 billion cells in your fingernail to map all the chemical connections.
Disassemble and reassemble
Yeah.
too hard, but yeah, just, yeah. Way
No,
beyond.
disassemble. So you didn't like Lost in
Yeah.
Space?
Yeah, we watched that.
Will Robinson is approaching. Will Robinson, warning, Will Robinson.
Well, they
You
were,
were June
I
Lockhart.
agree with, yeah, they did give us widen our perspective. What would it be like if we could go someplace else? Other planets, what might we encounter?
Rosie
And
and
how would we react? Yeah, I thought Star Trek was especially good with that.
What would scare your pants off is War of the Worlds. You know?
Yeah.
Yeah, that's.
Bad.
I like
Coming down.
contact. It's not about aliens, but it's maybe like going to a different contact.
Contact,
Then she meets her dad and then she comes back in time, hadn't gone on, like. I don't know,
yeah.
makes you think about different dimensions.
What do you think about the theory some people have that God is actually, the concept of God is actually an alien from some other planet that visited here long ago, seeded our planet and our race, and then left and is watching from somewhere else? Some people theorize that.
Somewhere else, we are always searching for an explanation that fits the way we want it to fit. Not so much as we're too open-minded to think that things may be totally different than we could ever explain. We just want it to fit what we know.
That's the problem with creation science. They've got this one view, they don't want to understand anything else.
I think that's where different dimensions comes in.
And I think theologically, I think it's good for us to not bind ourselves in a box. Not be afraid of questioning and discovery.
Absolutely.
There's a lot of people that are terrified. They've got some theological perspectives that are in a little very tight box. And they're terrified, think outside that confine, as if God's gonna Thor's gonna throw a lightning bolt at him. And I think as long as you've got the concepts of love and justice, kindness, treatment to other people, you don't have to be afraid of exploring.
Well, the recognition that the Bible is not a science book, it's not a science text.
Yeah.
That recognition.
Okay, we're out of time. Any final questions, comments?
This was great, Rob. This was great. Thank you.
Susan said it was good.
Okay.
Toby, what was your comment?
It's just so enormous, it boggles the mind, and it gets so big that you don't even want to think about it, because you can't. I mean,
And just the part we can see
Yeah,
so
yeah.
far is so amazingly huge,
It's
But it's
exciting.
so fun.
but it's fun.
Do you think it's
Well, we have to inspire young people to look ahead, to want to question.
Yeah,
That's the
Right.
first question.
right.
do you think other animals can see like colors that we can't?
Absolutely. We know a hummingbird can see a light frequency off of flowers that you can't. So when you see a rose, you see mostly red, if it's red roses, but a hummingbird can actually see. Yeah, its ability to see different frequency of lights is better than ours. And I think there's some other creatures in the,
Like dogs. Dogs smelling
Yeah.
oh, yeah,
1,000 times more than we can.
right.
Yeah. And hearing a much wider range of things.
It's all
Yes.
part of the electromagnetic spectrum,
Right.
from radio waves to microwaves.
We gotta wrap up, but Rosalind, the last comment.
Yeah, I always heard that if it wasn't for the moon, the earth would burn up, the sun would burn the earth up. The moon, goes like, when the sun comes, the moon goes around. That keeps the sun from hitting the earth to the point where we would burn up.
I don't think that's, no, I haven't heard that.
Hey, I even heard that on TV, on that science. Yeah. And I have known that forever. Somebody,
We'll check that out.
yeah,
That reminds me, just a plug for a radio show called Science Friday. And NPR about 1 o'clock on each Friday.
Yeah.
Wonderful show that talks,
Right.
yes, talks about these kind of things. NPR
Yeah.
Fridays about 1 o'clock in the afternoon.
that's what they say is the reason for the earth warming, because the moon changed like, changed.
Okay, very good.
Yeah, check it.
We'll check it out. Okay, thanks everybody for coming.
Thank you. Bye.
Bye-bye.
Nice to meet you.